What's up guys, it's me CJ, welcome back to another math tutorial. Now I'm going to try and get this done in one take because I don't want to do no editing, none of that. But first thing we got to do in our lesson, my lesson, that's pretty cool to say, but first thing we're going to talk about are why are these not U sub problems. So first up we got this problem right here. Why is this not a U sub problem? It's a function in a function, and like as I went over the other day when I did my U sub tutorial, that's when you use U sub. So it should work, right? Sorry to break it to you, but I tried the U sub, and what happened was there was still x's left in the equation, and we need it to be all u's, which is why we do U sub. But so that's not good. It doesn't work, and maybe that's just a freak accident. Hopefully that's like the only time it happens. Well, what about this one? Function over a function. Use the denominator, turn that into u, and then it should be fine, right? No, I did U sub for this one too, and there is still x's in the problem. Heart broken. But you need to repair that heart, because sometimes it's not going to work. Sometimes U sub, even though it's goated, sometimes it's not going to work. And you need to approach the problem from a different point of view. So if we go to this one, let's go back to number one. Let me scoot this up here a little bit. Go back to number one. We got x squared plus 5 squared. And what you're going to want to do is you're going to see that this is basically equal to x squared plus 5 times x squared plus 5. And now you're just going to multiply it out. So we must multiply out, yeah. So this should turn into x to the 4th, because we got these two here. Then we're going to get plus 10x squared, because we got 5x squared and 5x squared, and plus 25. But now it's just super easy to solve. All we got to do is just use antiderivatives. So what this turns into is, sorry about that, my microphone disconnected for a second there. But anyways, all we got to do now is just solve it using our antiderivatives. So this should be x to the 5th over 5, and you just do this in your head, plus 10x cubed over 3, right? Plus 25x plus c. Boom. Now we got our answer. So, yeah. All right, but what about the second one? So, what we're going to learn in a second here is that when you see a function has a bigger number over a smaller number function, so for example, we got x cubed, which is bigger than x squared plus 1, what we're going to have to do is long division. Now, in case you forgot about long division like I did a couple days ago when I was learning this stuff, I'm going to do a quick review here. So, what you're going to do, put the numerator underneath this little bar thing. What we're going to have to do is, since my microphone cut out, I'm going to have to say this again. So we're going to take the numerator, we're going to put that underneath the bars, and then we're going to put the denominator outside, x squared plus 1. Now, what times x squared times what is equal to x cubed? If you said x, you're correct. So we're going to put x. Now we're going to do x times x squared and x times plus 1, which is equal to x cubed plus x. And then we're going to end up minusing both of these. So we should just end up with minus x. So now, what is x squared? What x squared times what is equal to negative x? Well, in order to solve that, we're going to need to use a fraction. And when you have to use fractions, you're out. So what we're going to do now is we're just going to take our remainder, and we're going to do plus our remainder over our denominator of our original function. Boom. Now what we're going to do is, instead of finding integrating this, we are going to integrate this. So this should be equal to x dx plus negative x over x squared plus 1 dx. So Now from there, it's going to make it a lot easier. We are still going to have to use a little bit of u sub. So this should, so for this one, for just this one, and then, so this is going to become u equals x squared plus 1. And if you don't know u sub, watch my tutorial that I posted the other day. Du is equal to 2x dx. And solve for dx. So I'm low-key running out of pages here, but we're going to try and fit it in. Plus sorry, I'm a little quiet here. Gotta focus, a little bit tired. So negative 1/2 times 1 over u du, which, alright, I'm gonna just finish this over here. So this should become x squared over 2 minus 1/2 natural log of the absolute value of u plus c. Right? Oh yeah, and then we gotta plug in u as our last step. So that should be x squared over 2 minus 1/2 natural log of x squared plus 1, the absolute value of x squared plus 1 plus c. Alright, we barely fit that in, but we did get it done. So, on to the next one. So, basically what I was trying to show you from those examples is that sometimes you're going to need to approach things from a different perspective. Sometimes you're going to need to rearrange things in order to find the correct answer. And, that's kind of how it is in life. So, yeah, you learn life lessons from math. Who would have thought? So, but another thing that we can do to rearrange things sometimes is completing the square. Now, in case you forgot completing the square, I did too. Let's do a little bit of review. So, what we're basically trying to do is we're going to try and turn this into this. Make sense? Alright, so we already got a plus k, and that's our plus 8. So we're going to set that aside. Can you hear that? They're having a party out there. So, got some Kendrick Lamar playing. I don't know if you guys can hear that or not, but, yeah. So we're going to set that aside, and as it looks like right here, we can factor out 4. So this is going to become 4x squared plus 2x. And now we're going to leave a little bit of space here. And also we're going to leave a little bit of space here. So to complete the square, what you're going to do is you're going to find a number here that will make this into a function that you can just easily find, like the I don't know, I guess the square root. So how you do this is you take this middle coefficient here, take 2 over 2 squared, which is equal to 1. So then it's just plus 1. And so now we just added on a 4 times 1. We added on 4 to the equation. So how do we undo 4? We got to subtract. So over here we're going to subtract what we had, which was a 4. So subtract 4. And looks like I did everything right. So we should finish with 4x plus 1 squared plus 4, which is how you complete the square. And now, as you can see, it matches this. Alright, let's do one more. Negative x squared minus 6x minus 8. So what we're going to do, it looks like we can factor out a negative here. So what we're going to do first, though, is we're going to take this 8 to the side and factor out the negative 1. So we should have x squared plus 6x, and then leave some space here. So now we got to complete the square. So 6 over 2 squared, that is equal to 9. So we're going to add a plus 9. And now we just got a negative. We just added on negative 9. So how do we do that? We got to add on 9. So now we should end up with negative x plus 3 squared plus 1. And I believe that's the right answer. So yeah, that's how you complete the square. And we're going to use that in a second. So stay tuned. All right. But first things, before we move on, you gotta remember some stuff. And what you have to remember is the integrals of trig functions. So you gotta remember all of them for like your tests and stuff. But for this example, we're just gonna have to remember that 1 over x squared plus 1 dx is equal to the arctangent of arctangent plus c, arctangent x, right? So alright, so for our first example, I decided to get out a fresh piece of paper because there's a lot of work that goes into this one. So I don't want to run out of space like I almost did the last one. But yeah, so let me rewrite it. So we got on the, I don't even want to pronounce this. This is just a whole mouthful, but you guys can see it on the paper. So yeah, this is going to be our example. So as you can see, we have a bigger function over a smaller function, x squared over x. So that's, like I said earlier, that's a telltale sign that we're going to be long dividing. So yeah, let's do that. So we're going to put the numerator under here, put the denominator here. X times what is x squared? X times x is x squared. So now we got to bring it back. X times x, x times 2x. So we're going to get minus x squared plus 2x, which is ending up going to give us a negative 3x minus 5. And yeah, so now x goes into x times what is negative 3x? Negative 3. So negative 3, we're going to put that in for there. Then that's going to turn into negative 3 times x, negative 3x, negative 3 times 2, negative 6. So we're going to end up with a remainder of plus 1. Then we're going to take the remainder, put it over the denominator, and now we are ended up with 1 over x plus 2. And now we're going to integrate that. So let's go ahead and do that. 2 to 1 of x minus 3 . Now, if you're a studious observer, you may notice that this can be turned into 2 parts. It can be split up into 2 parts. You can integrate x plus 3 and then do that for the other side. So let's just start off with this side. So let's just do the antiderivative first. So we're going to have x squared over 2 minus 3x. You can put a plus c if you want. Your teachers will probably want you to. I wasn't going to do it, but I mean, I guess I'm going to, because I want you to get a good grade. I want myself to get a good grade. I want to get into a good practice of doing that. So yeah, now this is going to be on the interval from 1 to 2. So we got 2 squared over 2 minus 3 times 2 plus c minus, in parentheses, we're going to have 1 squared over 2 minus 3 times 1 plus c, which, doing some math in my head, will turn into 2 minus 6. These c's will just cancel out. 2 minus 6 minus 5 halves, right? So negative 4 plus, and then this is going to turn into a plus because that minus. And yeah, there we go. And then I guess I'll just leave it like that. Why not? And well, actually, yeah, we need to go a step further. So that's equal to 2 1/2 minus 4. So negative 2 1/2. Am I right? I think I'm right. Negative 2 1/2. So that's the first side. Now we got to do this side. So it looks like we're going to have to do some u sub here. So x plus 2 is equal to u, or it's usually better if you u sub from this side. So u is equal to this. du is equal to just dx. 2, we're going to have to integrate that into, or we're not going to integrate that. We're going to have to put the 2 in for this right here. So this is going to become 2 plus 2, and then 1 plus 2 on this interval of 1 over u du. So now this is going to become natural log of u on the interval from 3 to 4. So natural log of the absolute value of u, or of 4, I should say. Yeah. 4 minus the natural log of the absolute value of 3. And then we got to put these together. So this is going to equal to -2, 1/2, plus natural log of absolute value of 4 minus natural log of absolute value of 3. So there we go. Did we get that all in there? Oh, I just missed the last part, but basically I just combined these two, so -2/2 and the natural log of 4 minus natural log of 3. So that gives us -2 1/2 plus natural log of the absolute value of 4 minus natural log of absolute value of 3, which I believe is the correct answer. Now you can simplify it even more if you want to. I'm not going to because I just don't want to, but I believe that's the correct answer. If I did something wrong, can someone please correct me in the comments? But I'm pretty sure that's the right answer. So yeah, let's move on to our next example. Which, well, is there even anyone watching this? If there isn't, anyone is watching this and they know something wrong, please comment below. Alright, on to the next example. Alright, so the next example that I want to do is, remember I talked about memorizing our trigonometry integration functions. So the next problem that I want to do is integrating 4 over x squared plus 4x plus 8. Now, to me, these are really similar. The arctan function and this. You got like a constant at the top, and then you got an x squared function at the bottom. So we have to try and make them pretty much exact. And how do we do that? Well, we're going to be using completing the square. So what we learned earlier, completing the square. So what we're going to do, we got 4 over x squared plus 4x, leave some space here, and we don't have to factor anything out, plus 8. And if you notice, like, this starts off with x squared, so that's why we're doing the complete the square, to make it so it's x squared plus something, or something squared plus something, and then we can use u sub to turn that back. And then so basically it'll end up becoming 1 over u squared plus 1 in our u sub, and then it'll make it super easy from there. So 4 over 2 squared is 4, so plus 4. We're going to minus 4 over here. Then this will turn into 4 over x plus 2 squared plus 4. And yeah. So now what we got to do is, we're getting there. We're getting close, but these are 1s. These are not 4s like we have here. We need to turn that into a 1. So how do we do that? Well, we're going to have to factor out a 1/4. So what do I mean by that? Well, let me show you. So we are going to go, we got 4 over here, or we're going to factor out a 4 is what I meant. And then we're going to factor out 4 out of this equation. So this is going to become 1/4 times x plus 2 squared plus 1. And then these should cancel out. And we got 1/4 times x plus square root. And then if you multiply those together, 4 times that is equals x plus 2 squared. And 4 times 1, that's 4. So we're good to go here. And Oh wait, looks like, make sure you have your parentheses here. So we got 4 times 1/4 times x plus 2 squared, which is equal to x plus 2 squared. And then we got 4 times 1, which is equal to 4, which makes us go to our original equation, and that will turn that into 1. So that's definitely a little bit of a mouthful. But now what we got to do is that we got a 1/4 on the outside here, and we got to put it inside of that so we can turn it into our u thing. So how do we do that? Well, we're going to turn this into, we're just going to move this into the equation. I'll just show you. So we're going to be integrating 1 over what's now going to turn into 1/2 x plus 2 squared plus 1. So now look, 1/2 squared, that is going to be 1/4, and then x plus 2 squared is x plus 2 squared. So that's gonna, this is going to be 2. This is going to become 1/4 times x plus 2 squared. So yeah, that's definitely, it's a little confusing, but hopefully that kind of makes sense, or I sort of explained it all right. So now u is going to become this inside function, 1/2 times x plus 2. So du is equal to 1/2 dx times 2 times 2. 2 du is equal to dx. So now we got 1 over u squared plus 1 times 2 du, which if you look up here is exactly what we're trying to do, except now the x is a u. So now we can just turn this into, oh, actually, we can move this 2 to the front here. So 2 times 1 over u squared plus 1 du. So now that's going to turn into 2 tangent, or the arctangent of u plus c, which is going to turn into, at the end, 2 tangent to the negative 1, 1/2 x plus 2 plus c. And that is our answer. So I don't know if I explained that the best, but let me just go through the steps one more time. So first thing we did, we completed the square to get it closer to this form of 1 over x squared plus 1. We got rid of that little x, you know, the coefficient times the x, because that's not part of this. So then once we had that, we turned our 4s into 1s by factoring out a 4. And in turn, we had to add a 1/4. So to get rid of that, we move that into the square function. And then once we had that, we could turn that all into u, put that into then it'll match this equation pretty much perfectly. We floated out a 2, and we ended up with this perfectly, so that just turns into tangent, or the arctangent of u plus c, and then we have the 2 that floated out over here. Then we plug in u, and that is our final answer. So yeah, that's everything you need to know about long division and completing the square. I hope I explained it somewhat well. I'm still not a master at this myself, and I'm just trying to, I usually just make these videos just to help myself study. But yeah, thank you for watching. If anyone did, I hope this helped. I really do, and it definitely helped me. So yeah, thank you. Everyone have a nice day. For those of you still watching, you guys made it to the secret demon u sub problem. Now, this is an extra thing. It doesn't really have to do with what we just learned. I mean, it actually does a lot, but this is just kind of a fun thing. So if you want to try the demon u sub problem with me, just go ahead. So we're going to be integrating 1 over 4x squared plus 9. And I'm telling you right now, this looks like the arctangent function. So we're going to have to somehow turn this into this. Now, how do we do that? Well, first off, we have a plus 9. This has to be a plus 1. So what we're going to do is we're going to factor out a 9. So this is going to become 1 over 9 times 4 over 9x squared plus 1. And since this is pretty easy to float to the front, we'll just do that. So that becomes 1/9 times 1 over 4/9 x squared plus 1. So now we're already pretty close, but look, the 4/9 has to be squared along with the x. It can't be outside. So what we're going to do is we're going to take the square root of both sides, which luckily is pretty easy, which will it's going to end up being 2/3 x squared plus 1. And there we go. Now it is matching the arctan function. So u is going to be equal to 2/3 x, and du is going to be equal to 2/3 dx. So now we're going to plug all this stuff in. So 1 over u squared plus 1, that's just the tangent. So we got 1/9 times, oh yeah, I forgot to put the 3/2 du. I felt like I was missing something there. Forgot the dx, and then we got the 2/3, oh, I didn't even solve for dx. I'm tripping. So that's going to be times 3 over 2 times 3 over 2. So 3 over 2 du is equal to dx. So 3 over 2 du. So that's going to become the tangent. And also we can float this to the front. So we got 1/9 times 3 over 2 times the arctangent of u plus c, of course, never can forget that. So we got, we can cancel this out here. So we got 1/3 times 1/2. 1/2 times tangent, arctangent of u plus c, which is going to become, oh my gosh, how far? Okay, so luckily I didn't miss too much there, so all I did was I was able to cancel that out. So then that became 1/3 times 1/2 times the arctangent of u plus c. Now this is going to turn into 1/6 times the arctangent of u plus c. Now all we gotta do is plug in what we got for u, which was 2/3 x. So 1/6 times tangent -1 2/3 x plus c, and that should be our answer. So yeah, now I'm actually done. So thank you everybody for watching. Have a good day, and enjoy yourself this weekend, this break, whatever you're doing right now. For me, at this current time, it is rodeo break, but make sure you take time to study, take care of yourself, eat healthy food, go get some exercise in, and just take care of yourself and be happy. Take the real dopamine over the fake dopamine, if you know what I'm saying. All right, that's enough yapping for me. I'm out of here. Have a good day, everyone.